Thank you very much for the opportunity to present. Thanks for sharing the session and the invitation. Me and my colleagues from the Technical University of Munich worked on the evaluation of our autonomous driving dumper using a robot evaluation framework, which is not this one was developed by Cynthia from Stanford University during her PhD, and we tried to combine this within our joint lecture. So first and foremost, then you know the challenges our industry faces. So we have the labor shortages, we have in Germany at least a slow and rigid qualification process. So 3 years training to be a machine operator, to be a certified heavy machine operator. We have this lowest business challenge in Germany, which blocks lots of innovation in procurement phase, especially in machinery. We have a resistance to change, and that became really evident when we visited the training ground of the Bayerische Bauakademie, where we arrived with our electrified machine first and foremost, which were really practical, and then it was driving on its own. So this one was some new machines in the but we tried to get this in the right direction. And also there we have some integration gaps. So limited experience while integrating robotics on our side, for example. And of course, you all know about this demand and productivity gap, where we have a growing demand, which is growing way faster than our capacity to build. And we believe that the construction robotics offers a solution. In this video, you can see our dumper, the DT10 from Wacker Neuson, which we developed jointly with ultrasonic sensors. We also
a training data set,
GPS as well for navigation there.
And then we
it can be operated
remotely
autonomously. And you can see my colleague Anne guiding the robot with some gestures, and the robot will follow her. And my colleague Lucas lays down some markers in
the main idea is to standardize.
Here we have a self-learning, and then the GPS for the driving, and also, of course, we cannot operate without a safety system. For that. And you can hear that German construction side of New Zealand, but on the side, the worker can focus now on value-adding tasks and not this bulk material movement.
And we also consider
so the autonomous construction equipment market is estimated to rise to 17 billion in 2032 with a CAGR of 7.5% per year. This brings us to a question: how can we evaluate whether our developed construction robotics are actually feasible to deploy on site? And that's where the REF comes into play. So we need a systematic evaluation tool, and there we try to evaluate dumper using the Robotics Evaluation Framework from Cynthia. And how it looks like, I will show you in the following. So first and foremost, a general introduction to the REF. It offers a systematic evaluation approach. So on the left-hand side, we have the client and the project objectives. In the first stage, the general contractor analyzes whether it's feasible to deploy the robot on site. And the POP, so product, organization, product evaluating the robot features for the work environment, communication, status, whether work organization, behavior, different environment here, and the process then covers any operational changes when switching from manual process to automatic process. So we can determine whether it's feasible or not, and then we need to weigh in the second stage our priorities. SQSD, the safety, quality, schedule, and cost. So measures quantifying the impact, accidents, ergonomic strain, and hazards for the construction site and the workers. Evaluating the accuracy of the construction robotic work, and the schedule basically looks at the differences in the manual process and the autonomous. The cost, we compare the initial investment and long-term returns. After that, now we calculate in the REF the topsis weights. We provide some recommendations. So let's start with the first question, whether it's
Thank you for your presentation. Any question or comment?
POP analysis.
Okay, yes, please.
So for the product variable, we have a high rubility of the dumper in both cases.
Data set.
In the autonomous case, we have robots.
Thanks for the really interesting presentation. My name is Justin Lee from Yuan-Jen University, South Korea. During your experiments, did you consider the excavator actually being loaded with soil versus empty? Because there's the behavior and damping and stiffness would definitely change as there's more load being applied to the scoop, right? So I was wondering if you had that as a variable within your experiments.
Same safety critical part of stopping when it's
Provide the
So overall, we can see that the POP analysis paints the picture
and then
that we can deploy the dumper. That's feasible to use on the construction site in the first step.
then we
For the second part, we after determining feasibility, we now need to weigh our variables. So for the safety, we assigned a
Matching and then the friction and then also the scoop and then the load, right? The load of the soil also.
The ergonomics and the convention. Ergonomics, simply because no one has to stand on the dumper and back the dumper and subject to this vibrations there. The quality for the bulk material transport, it's pretty irrelevant when we assign the value of 0.1 because it's not that quality intensive, I would say. For the sketch,
Continue the previous questions. So the data you obtained in the experiment is
some areas need to be clear.
obtained
Other
in
processes to start.
the motion in the air
Always
and also
but not the highest
does it
priority
touch with
here,
the ground?
but also important for competitive deployment.
we created
So when
So
does it
we
touch
want to focus
with
on
the
the
ground?
ground first of these variables.
to a standard
You can see that the
to meet the
normal dumper, the one you can buy off the rack,
people detection.
takes the cycle time for a predefined cycle by my colleague Bernhard about 136 seconds. The dumper, the autonomous one, is a lot higher, with 181 seconds.
Which is to a
This is mainly due to
Anyways, the
dri-
data
autonomous one
contains
driving
the
a lot
motion
more
in the air and also the
meet
contacting
safety
motion with the ground.
requirements and time.
people
You can see the human in the picture
Okay, yeah.
only for the start and the issue order.
are more advanced.
Other processes can be done autonomously with our dumper.
On that graphic, can you point out,
Let's have a look
because
at the
I don't see much the
valuation
color over there.
of the
Which one is the
weighted,
actual data and which one is the simulated
for
data?
safety,
Because I can differentiate the two.
that tremendously improves the ergonomics and also reduces the operator strain I previously talked about. For the quality, transport quality, pretty much comparable to the conventional dumper, if not even better.
Yes, but around the 10 seconds, there's three curves. Can you tell me which one are from left to right? Because I don't know if the left one is the input data, but the middle one I can't differentiate if it's the actual data or the
Years in
simulated
our
data.
scenario. So after typing in all those numbers, ref, and
Hello.
Tops's weight,
Thank you for the presentation. It was amazing.
Length
What I want to ask is that did you ever think about
this could be
combining
further
two different
developed,
robots with your exopod
perspective
that
more
you
depth,
present
but
previously and
for this
making
case,
a flying
the
aerial robot
manual.
so that you can avoid
questions?
There are
operate on one single device?
schedule time.
Do you think it's much
So
beneficial
plus
or
minus
operating in
25,
two different
50, and
systems is
75% changes in our framework?
Yes, please.
And the payback period for the robot remain constantly.
So how difficult is it now to plug this into an actual excavator to actually control, to automate a real excavator?
As far for the challenges, we have a limited acceptance.
How difficult is it to use your simulation tool to now control an actual
This is, I
excavator?
think, the biggest challenge here, the longer cycle times, which in the future may go down. These are due to the safety regulations we have. We need to stop 100% if it's human.
Your motivation is to automate real excavators,
Germany
correct?
is not that flexible.
So how difficult is it now
You still need
to
to be
apply
trained.
your research to an actual excavator?
Yeah, of course, it's safer, vibration-free operation for the operator.
So I
We
think
have the operator who supervise multiple units, and it should be scalable for fleet coordination, which we're already working on in a follow-up process. combining the dumper and a compactor.
Inconsistency.
So we see the REF as a tool for decision-making in construction robotics, and it's a unified and, for most and foremost, standardized process. So it's a point to start with evaluating.
Hello.
So
Thank
you
you
very
presentation.
much
Thank
for
you.
your attention.
So for the
We
simulation
look
environment,
forward to a
what did you use for
And like
that?
to end by
I don't
thanking
recall what was specified, and also what was your experience integrating robot and
Super pleasure.
vision
Thank to
methods
Professor Martin
with
Fischer
in the
from
latest
Stanford for letting us join the construction robotics class with Tom, and Wacker Neuson for the joint development of the dumper, as well as the Bayerische Bauakademie for the use of their training grounds for tests. Thank you very much.